Hello friends, my name is Vijay Kumar Das. I am a student in Mechanical Engineering Department in College of Engineering and Technology Bhubaneswar. I have started this YouTube channel to fulfill my desires of discussion on science. I will make videos basically for BPUT students, but everyone can get benefits from it. Thank you. Today we will start with the subject of basic electrical and electronics engineering. Okay, as we all know, it is just an advanced version of our plus 2 physics and the basics of the 4 years of electrical engineering and electronics engineering, the two different branches, but the basics are combined with one subject. Okay, let's get started. Today we'll start with the first module. Actually, the first module is very easy and it is just the recapitulation of our plus 2 physics course. So we'll start with the Kirchoff's laws. I think all of you know about this, and I'll just recapitulate the things. But if anyone is unaware of these facts, then he will be benefited. Actually, the scientist Kirchoff has given two laws. Okay, basically two laws. One is KCL, very easy one, and the first one is KCL, Kirchoff's current law. Okay, actually this is only the principle of conservation of charge. Okay, theorem of conservation of charge. It focuses on conservation of charge, and it states that at a node all the currents equal to 0. At a node, the sum of all the currents equal to 0. It means this is a node and this is the current I1, I2 and I3. Two incoming currents I1 and I2 and one outgoing current I3. So if we take the incoming is positive and outgoing negative, by applying KCL we can get I1 plus I2 minus I3 is equal to 0. This is the application of KCL, Kirchhoff's current law. Then we will see KVL. Okay, Kirchhoff's voltage law. Actually, this is also very easy. This is the principle of conservation of energy. Okay, these 2 points are very important short questions. KCL is principle of conservation of charge and KVL is principle of conservation of energy. Actually, the whole electrical circuits, every electrical circuits can be solved by 3 laws. One is Ohm's law, V equal to IR, and these 2 laws, Kirchhoff's current law and Kirchhoff's voltage law. These are the basics to solve every type of electrical circuits. Okay, this principle of conservation of energy. Okay, it states that the algebraic sum of all voltages in a closed circuit This is very necessary and important condition. The circuit should be closed to applying the KVL. Closed circuit or loop is equal to 0. Okay, and this is a circuit, and this is V, this is R, and the current flowing is I. Then it will start from this point, then we will get first negative to positive potential drop V plus, this is the current direction and we are going along the current direction, so we will use minus. Okay, I'll tell these rules in the next problem, how to solve this and how to apply the KVL. Okay, I will do one question in which I will show how to use a KVL and the rules to apply KVL. Okay, V minus IR is potential drop. This is Ohm's law, is equal to 0. It is a very the most simple circuit. So we will do one question. Here the question is, here this is a circuit. Here 1 ohm resistor, 3 ohm resistor, 2 ohm resistor, 4 ohm resistor, 20 volt battery and V battery, and the question is, and this is 20 volt and this is V. This is not volt, this is capital V. Okay, capital V, you have to find this V. So this is volt, but this is capital V. Okay, that is noted by W. You have to find the W. W is the voltage. Okay, let's solve it. First of all, we will decide the currents. Okay, we will name the currents in each branch. We'll assume, let the current in this branch is I. This is I1. This is I2. This is I3. Okay, and this I2, I3. This is I4. Here comes the I5 and I6. Okay, now we apply the KCL, first Kirchoff's current law for this. Okay, for this node, let's name the nodes A, B, C. Okay, for the node A, what the Kirchhoff's current law says, at any node to total current, here I want to show KCL. Okay, at node all the current equal to 0, sum of all the currents equal to 0, sum of all the currents equal to 0. So for node A, we can write I1 incoming is equal to I2 plus I3. Incoming current equal to outgoing current. Okay, for node B, here I3 coming, I4 going, I5 going. So I3 is equal to I4 plus I5. That's denoted by equation number 1 and this is equation number 2. Okay, for node C. Okay, Here the current I2 is coming, I5 is coming, and I6 is going. So I6 outgoing is equal to I5 plus I2. I want to say that the assumptions will be according to you. You can take any assumption. You can take I1 in this side also. You can take I2 in opposite side also. You can take I3 in this side also. All the assumptions will be according to you. Okay, and the answers will come equal according to your assumptions. If you are taking I2 in this direction and the answer is I2 in this direction, the I2 will be coming negative. So negative minus 2 ampere in this direction equal to 2 ampere in this direction. Okay, negative 2 ampere in this direction equal to 2 ampere in this direction. Okay, this is KCL. We have applied the KCL. Now it turns to KVL. Okay, now we will do KVL. We will write the KVL like this. Remember one thing that for this loop, let's take this loop. Okay, that will define we are going in this direction, right? We are going clockwise. Okay, we will going clockwise. If we'll start from this point and going clockwise, we will end this point. Okay, from this point we will first see this is minus, it is plus, so plus W. Okay, W. Then if you are going in the direction of current and meeting an resistance, then the potential drop will be negative. Okay, we are going in this direction and we are assuming current also in this direction and the resistance has occurred, so our potential drop will be negative. So minus 3i3. Okay, you understood or not? Minus 3i3. 3i3 from the Ohm's law, and minus is for we are going in this direction and the potential drop is in the same direction. Okay, similarly here minus 4i4 is equal to 0. Okay, for this loop. Okay, let's start from this point. We are going in this direction but current is in the opposite direction, so plus opposite direction. Okay, plus 4i4 in the same direction, so minus 2i5 here plus and here negative. We end at minus to minus 20 is equal to 0 for this. Okay, for this I2 minus I2. Okay, in this direction, so current is in this direction and we are going in the opposite direction, so plus 2i5. Okay, and here plus 3i3 is equal to 0. Okay, let this is 3, this is 4, this is 5, this is 6. From this 6th equation we will find out this W. Okay, we have 6 unknowns here. Let compile them into 3 unknowns. Okay, 3 or minimum number of unknowns. That's how we can put these unknowns into in this frame, and we will have minimum number of equation, and the minimum number of unknown needed, the minimum number of equation needed. Okay, here we can define I3 equal to I1 minus I2. Okay, here I4 is 3 ampere. It is given in question. Okay, in the second equation. Okay, 3 plus I5 is equal to I3. I3 equal to I1 minus I2. I1 minus I2. So I5 we got I1 minus I2 minus 3. Here I5's value, I3's value, I4 is 3. Okay, now question comes to I6. I6 equal to I5, I1 minus I2, okay, plus I2. I1 minus I2 minus 3 plus I2. Here I2 plus I2 cancel. I1 minus 3. I6 is equal to I1 minus 3. Okay, you got it. We have got I3, I5, I4, I6 in terms of I1 and I2. So we'll use two equations from it, and the two equations will be the simplest equation and including W also. This and this. Okay, let W is minus 3I3, 3I1 plus 3I2 minus 4I4. 1 second. We need three equations cause W is also unknown. We want the value of W. Okay, we don't know what is the value of W, so three equations are needed. I1 plus I2. Okay, better we will solve these two equations, find the value of I1 and I2 and put it in the W. Okay, here 4I4 minus 2I5 minus 20 is equal to 0, minus I2 plus 2I5 plus 3I3 equal to 0. Putting the value of I4, I5 and I3, we get 4 into I4 equal to 12. Okay, 2 into I5, I5 equal to 2 into I5. It means minus 2I1 plus 2I2. Okay, and here 6. Okay, is equal to 0. From here we get minus I2. Actually we are converting all the equations in form of I1 and I2. If we will get two equations in I1 and I2 and solve these two equations for two unknowns, and we will get I1 and I2, then we will put the I1 and I2 in this equation, putting first the I3 and I4 in terms of I1 and I2, then we will substitute the I1 and I2 by these values and we will get W. Okay, basic method is this. So minus I2 plus 2I5, 2I1 minus 2I2 minus 6 plus 3I3, 3I1 minus 3I2 is equal to 0. So our two equations will be I1, I am simplifying the equation, I1 plus I2 minus 9 equal to 0. Here 12 plus 6, 18, and by dividing 2 minus 2, I1 minus I2 minus 9 equal to 0. Okay, from this we get minus 2I2 minus I2 minus 3I2 minus 6I2, 5I1, 5I1 minus 6I2 minus 6 equal to 0. Okay, solving this, here we got I1 is equal to 48 and I2 is equal to 39. Okay, so I3 is I1 minus I2. Okay, 48 minus 39 is equal to 9. Okay, so W is equal to minus 3I3 minus 4I4. Okay, minus 3 into 9 minus 4 into 3 minus 27 minus 12, and this is something minus 39. So here is the W from this question. So we found out the value. Okay, and if you want, please write in the comment box. We will solve more questions on this, and in the next video we will discuss on the node analysis. Thank you. Please hit the like and subscribe button for more videos.